No.
Yeah, actually, so that's why.
Yeah, I'll go right down. Okay, so yeah, I'll answer
Join us for a working demo.
Yeah.
Over there? Yeah. All right, great. Sounds like a good plan.
Okay, we're so excited. Rahul, tell us what we're looking at and what we're going to see today.
So what you see over here is an autonomous go-kart. So it's a self-driving go-kart. And so this has many very interesting features in it because it is drive-by-wire, steer-by-wire, brake-by-wire. I'll explain what that is. But the most important part is that all of this was built by these students here, right? And they are masters in robotics at the University of Pennsylvania. So the mechanical parts, the electrical, the controls, the embedded parts, and it's also autonomous. It has sensors, it computes, and then it can drive. And so I'll hand it over to each one of them, and they'll talk about one subsystem. So go ahead, Jason.
Sure. Hey, everybody. Thanks for taking interest in our project. So I'll talk about the steer-by-wire system. So the difference between steer-by-wire and normal steering is that rather than a mechanical transmission of motion from the steering up here to the actual wheel angles down here, they basically happen in two separate subsystems, which will enable autonomy, but I'll get to that in a minute. So up here, you'll see that if there's a driver sitting in there, then he can just send commands in by moving the wheel as any normal driver would. But then this actually gets captured by a sensor in here, which measures the angle that it's at. That gets sent through a microcontroller, through a CAN bus system that then gets sent through multiple other microcontrollers. And then that signal gets translated into a proportional steering signal, which would happen by the lower steer-by-wire signal here. Conversely, if you don't want to have a manual driver sitting on board and you want to just go in autonomous mode, then instead you would have some higher level planner and higher level controls algorithms running. I'll let my coworkers talk about that in a minute, but then you would basically have the autonomy doing all the planning for you. And then that would, from a higher level, decide where you are, where you want to go, how you should get there. And then that'll ultimately translate to lower level control signals, which tell the wheels exactly how far to go. In order to get to that point, you tell the microcontrollers, exactly what binary code to send. Yeah, so.
Yeah, so maybe Tejas, you can explain this part. Yeah.
Hi, everyone. So, yeah, I'm going to just talk about like the overall system of the car. So, yeah, as Jason said, like you can see the steer-by-wire mechanism right here. So I can control the entire car with just a remote controller. To sum it up, the entire car has 3 different modes. It has a manual mode, which basically is evident here. You can just sit in, drive it like any other go-kart that you would do in any speedway. The other one is a remote control mode, which is basically controlling the entire car through remote control. This is actually pretty cool because all these subsystems that you see here, the steering, the throttle, which I can also show you right now. Yeah, the throttle system is something that looks like this. And it can go like really fast if you want it to. Like given the right conditions, it can go to up to 150 miles an hour. But right now, unfortunately, that's not the right condition here. Yeah, I talked about the subsystems. The autonomous part is what we're all here for, the cool part. We have a bunch of different sensors right here. Specifically, we have a 3D LiDAR, which gives you information about all of you standing right here. Like it's gonna see you here, and basically, as like humans would, it'll just see, okay, there's an obstacle right there. We don't want to go there. Like, okay, drive away from it. Other sensors are GPS, everything that you have in your standard mobile phone, IMUs, and all of that. Basically, the car knows where it is and what it's doing at every point of time. So, yeah, we can show the car on the ground as well. Moving on.
Yeah, so Raj, maybe you can. you can say something about the brake-by-wire system.
Yeah, so we have other systems like brake-by-wire where when you actuate it, it just passes a fluid through the brake and it just stops the brake. And then we have like perception systems where we have gap follow strategies where it just looks at different kinds of lanes. It projects it into a bird's eye view. And from the bird's eye view, it detects the coordinates of the lane and then it tracks the lane easily. You can even do grass tracking. And there is like a planned approach where you have GPS waypoints logged. And once you have the GPS waypoints, you can try to track those waypoints based on your controller, like a PID or an MPC controller based on the motion model. And that is how we like proceed with the autonomy of the car.
Yeah, so even though we won't be driving it fast, very fast here because a lot of people, but this vehicle and this team won the autonomous karting competition in May in Purdue in both the championships. And this whole vehicle was built by them in 5 months, right? So now we can take a look at the system on the ground.
I switched over to my camera minus.
So the main thing is that this car is completely open source. Everything is documented and anyone can make a copy. Just like we have the 110 scale cars inside, over 80 universities use that, and now anyone can build this car on from the AV4EV website. Yeah, so now we're just going to drive it down, take a turn and come back, but you can imagine on a go-kart track it would drive, very fast on its own. So let's take it away. So this car obviously has also multiple safety systems on it, and so what Jason is holding is a dead man switch, and so anytime you can stop the car.
I think it's trying to, yeah. I don't think it could have done other than its turn gradients.
Yeah.
Would have been good enough to make a full loop.
Yeah, so we welcome any brave soul to come and ride in it.
We also have a reverse mode, so we can also.
Yeah, so this is probably under 5% of its
Chandani, you want to? They will. You want to ride?
It doesn't have to be a speed limit.
I can take a ride.
All right.
Can I video on my phone?
No, I'm just kidding.
I guess.
Darn.
Let you drive without.
I don't know if they got the insurance.
Can you drive without you?
You have to sign a waiver.